In this session, we are going to talk about 11 physics, chapter number 4 laws of motion, part first. First point is importance of Newton's first laws of motion. First, it shows an equivalence between state of rest and state of uniform motion along a straight line, as both need a net unbalanced force to change the state. Both these are referred to as state of motion. The distinction between state of rest and uniform motion lies in the choice of the frame of reference. Second, it defines force as an entity or a physical quantity that brings about a change in the state of motion of a body. That is, force is something that initiates a motion or controls a motion. Second law gives its quantitative understanding or its mathematical expression. Third, it defines inertia as a fundamental property of every physical object by which the object resists any change in its state of motion. Inertia is measured as the mass of the object. More specifically, it is called inertial mass, which is the ratio of net force magnitude of vector F to the corresponding acceleration magnitude of vector A. Next point is importance of Newton's second law of motion. First, it gives mathematical formulation for quantitative measure of force as rate of change of linear momentum. Second, it defines momentum p is equal to m into vector v instead of velocity as the fundamental quantity related to motion. What is the change by a force is the momentum and not necessarily the velocity. Third, Aristotle's fallacy is overcome by considering resultant unbalanced force. Next point is importance of Newton's third law of motion. First, it defines action and reaction as a pair of equal and opposite forces acting along the same line. Second, action and reaction forces are always on different objects. Next point is consequences of Newton's laws of motion. Action force exerted by a body X on body Y, conventionally written as vector Fyx, is the force experienced by body Y. As a result, body Y exerts reaction force vector Fxy on body X. In this case, body X experiences the force vector Fxy only, while the body Y experiences the force vector Fyx only. Forces vector Fxy and vector Fyx are equal in magnitude and opposite in their directions. But there is no question of cancellation of these forces, as those are experienced by different objects. Forces vector Fxy and vector Fyx need not be contact forces. Repulsive forces between two magnets is a pair of action-reaction forces. In this case, the two magnets are not in contact. Gravitational force between Earth and Moon or between Earth and Sun are also similar pairs of non-contact action-reaction forces. Next point is inertial and non-inertial frame of reference. Let us consider yourself standing on a railway platform or bus stand and you see a train or bus moving. According to you, that train or bus is moving or is in motion. As per the experience of the passengers in the train or bus, they are at rest and you are moving in backward direction. Hence, motion itself is a relative concept. To know or describe a motion, you need to describe or define some reference. Such a reference is called a frame of reference. In the example discussed above, if you consider the platform as the reference, then the passengers and the train are moving. However, if the train is considered as the reference, you and platform etc. are moving. Usually, a set of coordinates with a suitable origin is enough to describe a frame of reference. If position coordinates of an object are continuously changing with time in a frame of reference, then the object is in motion in that frame of reference. Any frame of reference in which Newton's first law of motion is applicable is the simplest understanding of an inertial frame of reference. It means if there is no net force, there is no acceleration. Thus, in an inertial frame, a body will move with constant velocity, that is, which may be zero also if there is no net force acting upon it. In the absence of a net force, if an object suffers an acceleration, that frame of reference is not an inertial frame and is called as non-inertial frame of reference. Measurements in one inertial frame can be converted to measurements in another inertial frame by a simple transformation. That is, by simply using some velocity vectors, that is relative velocity between the two frames of reference. Hence, inertial and non-inertial frame of reference in animation is explained as
frames of reference which are stationary or which move in uniform rectilinear motion are called inertial frames. Others are referred to as non-inertial frames. A non-inertial frame may also be defined as one in which there are forces of inertia.
Thank you.